Now what is the refractive index of this medium? Mu1. Okay, so you will write here mu1 multiplied by sine of I, multiplied by sine of angle with normal, multiplied by sine of I. This is equal to, in another medium, now see in another medium, refractive index of medium 2 multiplied by sine of R. Actually this angle you can take R. Okay, so you can write mu2 into sine of R. From here you can just find out mu2 by mu1, and when you will find mu2 by mu1 you will get sin I by sin R, sin I by sin R. Question number 1. Okay.
Okay.
Now you can see here this normal, this is the normal, and this is also the normal. Both are the normal, and this surface and this surface are parallel. This surface is parallel to this surface, and this normal is parallel to this normal. So you can say this normal is parallel to this normal, and this is the line. If this angle is R, okay, if this angle is R, so you can say that this angle will also be R, alternate angles. So now we will apply the Snell's law here at this interface. So for medium second and 1, for medium second and 1. So you can write for medium second and 1. Apply the Snell's law. Refractive index multiplied by sine of R. Refractive index, what is the refractive index there? Mu2 into sine of R is equal to mu1 into sine of E.
Yes.
Mu1 into sine of E.
Yeah.
So now from here we can find again mu2 by mu1. We will get sine E by sine R. Suppose this is equation number 2. Now compare equation 1 and 2. See, the left hand side of this equation and the left hand side of this equation both are equal.
Yeah.
It means that the right hand side of the equation must be equal to the right hand side of the second equation. So we can write, comparing 1 and 2, you will get sin I by sin R is equal to, this sin I by sin R is equal to sin E by sin R.
Yeah.
Sin E by sin R. Now multiply. So it will become sin I into sin R, sin I into sin R.
Yes.
This is equal to sin E multiplied by sin R.
Yeah.
Sin R cancel out.
Yeah.
Sin R and sin R will cancel out. So you will have sin I is equal to sin of E. So angle of incidence is equal to angle of emergence. So you can say E is equal to I. The value of angle of emergence you will get, that is equal to the same as angle of incidence.
Okay.
So in this way you have to apply the Snell's law. You should know how to solve by applying the Snell's law, the numerical. Okay. Okay, take the screenshot, then we will discuss another topic, real and apparent depth.
Yes. Yes.
Okay. So now see the concept of real depth and the apparent depth. So what is it? Suppose this is a water tank.
Yeah.
Water tank. So this is a water tank, means in this tank there will be water. And there is one object, you can suppose this object as coin or any other object.
Okay.
So this is the object here. And here is the water. And this water has the refractive index of N2. This water we are considering the refractive index of water as N2, and around it there is air, and the air has the refractive index of N1. Okay. So we are talking about here for two medium.
Yes.
For two medium we are talking here. Here can be any other medium. Here this can be oil also. This can be
Yeah.
oil also, and here
Yes,
is
sir.
water also around it. So we are talking about two mediums only. Those mediums can be air and water, air and glass, glass and water. Okay. Specifically, I am not talking about this is water and this is air.
Yeah.
This the concept of real depth and the apparent depth can be applied for any other two medium also. Okay. So this is the object, and this object is at a depth of D. This object you can see is at a depth of D, and this is the interface, or you can say surface. This is the surface. Okay, this is the surface of the water.
Okay, sir.
Just wait.
Okay.
Okay. So now see, one thing I have told you, from this object,
Yes.
suppose the ray of light, for the image formation, suppose the ray of light is like this. First ray of light is like this, suppose. This light ray is suppose like this.
Yeah.
And you can say that, sir, this light ray is changing the medium. It is going from water to air, or it is going from one medium to another. Then why there is no bending here? You can say. I have told you that whenever the light ray changes the medium, there is a bending of light, but here there
Yes.
is no bending.
No, sir.
Why? Because this is a normal incidence. Because this is the normal incidence. Here we have discussed this. Whenever the light ray fall normally on the surface
Yeah.
between the two medium, then it will go straight. There will be no bending of light. The first ray of from this object is suppose like this, and suppose the another ray from this object is like this. Here
Yes.
is the interface. Now this ray, this incidence is not the normal incidence, so here the refraction of light will take place as the light is crossing one medium and going into the another medium. So this
Yeah.
is the normal here. This is the normal here, and light ray is going like this. Light ray is going like this,
Yeah.
and now it is just about to cross the medium. So as the light is moving from denser medium to rarer medium, you can write
Yeah.
here N2 is greater than N1 here. In this case, you can say N2 is greater than N1.
Yeah.
Okay. It can be like N1 can also be greater than N1, but this is not mandatory. So, okay. So this is the, and suppose this angle is the angle of incidence. This angle is angle I. So what will happen as the light ray is moving from denser medium to rarer medium? Here the light ray is moving from denser medium to rarer medium, water to air. So it will bend away from the normal. It will bend away from the normal. We
Yeah.
know that. away from the normal. So finally the light ray will go in this direction like this. So when you will produce this light ray backward,
Yeah.
like this. When you will produce this light ray backward, so somewhere here, the image of the object will appear to the observer. Here
Hmm.
will be the image.
Yes.
Now, if somewhere here is the observer, this is the observer's eye. This is the observer's eye. So when you or the observer will see from here or here for here means from the rarer medium,
Yeah.
from the rarer medium or from this medium, the observer will see the object will appear here, not here.
Yeah.
This is the real position of the object, and this is the apparent position of the object.
Hmm. Okay.
And this depth of the object from this this depth of the image from this surface is known as the apparent depth, d dash. D dash is the
Apparent.
depth of the image from this surface. So now why this object in actual this object is here, but why this object is appearing here? Because due to the refraction of light, due
Yeah.
to the
Yes.
refraction of light. So actually now what will happen? The observer will be here somewhere, means anywhere you can say. So your eye, to your eye, it will appear that this light ray is coming from here. This light ray is coming from here. It will appear to your eyes, but in actual,
Yes.
the light ray is coming from here.
Yes.
Okay, the condition is different in actual, but what your eye, the incident for your eye, it will appear that the incident ray is coming from here, so it will appear that the object is here. It will appear that. So there is a relation between the real depth and the apparent depth. Okay. So D is the real depth, D dash is the apparent depth, measured always from the surface. Remember, always we will measure from the surface. N2 is the refractive index of medium from which the light is coming, and when the refractive index of the medium in which the light is going. So now you can see N2 is the refractive index of the medium from where the light is going. Means from the medium. N2 is the refractive index of the medium
Yeah.
from which the light ray is going, and
Yes.
N1 is the refractive index of the medium where the observer is present, or you can say where the light ray finally going.
Yeah.
Now there is a relation between the real depth and the apparent depth. Real depth and the apparent depth. Real depth and the apparent depth is given by the ratio of the refractive index mu to N2 by N1. N2 by N1 is equal to real depth divided by the apparent depth. So N2 by N1 is equal to real depth divided by the apparent depth.
Okay.
What is the real depth? D. And what is apparent depth?
D dash.
D dash. So this formula we will use to solve the numericals. Okay, now we will do the derivation of the same. Okay, we will do the derivation of the same. This is the object here, and this is some medium, and this medium have the refractive index N2, and here is another medium have the refractive index N1. An object is present here, Okay,
Okay.
and this is the denser medium and this is the radar medium, I am supposing. Means, so what will happen? First ray from this object, suppose this like this, it will pass straight.
Yes.
On changing the medium, there is no bending. Why there is no bending? Because this ray is going normal to the surface.
Yes.
And this is the interface of the surface separating two medium. So another ray of light from this object, suppose like this. Like this. Now, the light ray here is changing the medium. The light ray here is changing the medium. So if the light ray will change the medium, it will suffer some bending. According to the angle of incidence, it will
Yes.
suffer bending. So suppose this angle is I1, this angle is the angle of incidence I, and it will bend like this. It will bend away from the normal like this.
Yeah.
And when you will produce this in the backward direction,
Good.
so it will appear that this ray is coming from
Apparent.
somewhere here. Yeah.
Apparent image.
Okay, so somewhere here the object will appear to you. And what is this distance? This and this distance is d dash.
Hmm.
And this distance is the actual depth from here to here. This is the actual depth, that is d. And this ray we have produced backward, so this we can show white dotted line. And this is the normal. Now, one thing, this is the angle of incidence. Okay, this is the angle of incidence. This is the normal, and you can say this normal and this ray of light are parallel. So if these rays of light are parallel, then you can say this angle will also be the angle I. This angle will also will be the angle of incidence. Alternate angles. These are alternate angles. If this angle is I, so this angle will also I, because this normal and this ray of light are parallel.
Yes, sir.
Okay. And this is the angle of incidence. So this will be the angle of refraction. This is the angle of incidence. This is the angle of reflection. Now see, this is the line you have produced like this. You can say this can be the same line. And this normal and this ray of light are parallel. So if this angle is R, then this angle will also be R.
Because of the parallel.
Yeah.
Okay.
What is the topic? Means what is the chapter name? Geometrical optics. So we
Yeah.
are using geometry here.
Yes.
This is the geometry.
Yeah.
So now see, suppose this point is A, this point is B, and this is I image, and this is suppose O.
Right.
Now we will apply geometry or trigonometry to find the relation between the real depth and the apparent depth. Real depth and the apparent depth. Okay. So now at this interface, apply the Snell's law. So how you will apply the Snell's law? Refractive index of this medium, that is N2, multiplied by sine of angle with normal, that is sine I. Refractive index of another medium, N1, sine of angle with normal, that is R. Okay. Remember one thing,
Yes.
there is an assumption here. The assumption is that this ray and this ray both are paraxial. Paraxial means this angle of incidence is very, 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 very small. Angle of incidence is very, very, very small. Then you can say angle of refraction is very, very, very small. Okay, so this is this assumption we will use. So you can say rays from object are paraxial. So I and R. I and R means angle of incidence and the angle of refraction are very small. If this assumption we will apply here, then we can write sine of angle of incidence can be written as approximately angle of incidence I, and this can be written as tan I, and sine of angle of refraction can be written as approximately equal to angle of refraction, and this can be approximately equal to tan of angle of refraction. Now instead of sine I you can put tan I, instead of sine R you can put tan R. So in this equation,
Yeah.
in this equation put the value of sine I and sine R. So n2 instead of sine I we can put tan I is
Yeah.
equal to n1 into tan R. Finally we have this equation.
Yes.
Now we will try to find tan I and tan R. So we will see here. See this triangle. In triangle IAB. See the triangle IAB.
Yes, sir.
So this IAB triangle is right angled at A.
Yes.
This angle will be 90 degree.
Yeah.
This angle will be 90 degree. So see the triangle IAB. So you can write here in triangle IAB. Tan R we want to find. Tan R. This tan R we want to find. What will be the value of tan R? Tan of any angle is equal to the perpendicular divided by base. What is perpendicular? Perpendicular AB and base is AI. So
Yeah.
tan of R is equal to perpendicular. Perpendicular is AB and base is AI. AB is the perpendicular and AI is the base. So what is AI? AI is equal to D dash. You can write here AI is
Yes,
equal to D dash. What is D dash? Apparent depth. So you can write tan R is equal to AB divided by AI is D dash. Suppose this is your equation number 1. Now for finding tan I,
Yeah.
this is tan I. See the triangle OAB. See the triangle
Yes.
OAB. OAB is also a right angle triangle. So you can write
Yes.
in triangle OAB tan of I.
Okay.
Now tan I in this triangle will be AB,
Yeah.
AB divided by AO.
AO. Yeah.
AB divided by AO. AB divided by AO. And what is AB? AB is AB and AO is D. Now see what is AO. AO is this distance and
Okay.
this distance is equal
Distance.
to D. So you
Okay.
can write
Okay.
AO is equal to D. Okay. Now tan I we have AB by D and tan R we have AB by D dash. So suppose this is equation number 2. Now put tan R and tan I in this equation. So N2, what is tan I? Tan I is AB by D dash. AB by D dash.
Yeah.
And tan R is N1
AP by D.
into tan R AB by D dash.
So AB by D, right?
Sorry, AB by D.
Yeah.
AB by D, right. So this AB and AB will be cancelled out.
Yeah.
So what you will have? Just a minute. This is N2 into 10I. Actually, this is 10I, na? So it will be AB by D dash. So N2 into 10I. So 10I is AB by D, na? So here we will put AB by D.
Okay.
AB by D. And here we will put AB by D dash. Now AB and AB cancel out.
Yeah.
So you will get N2 by N1 is equal to D by D dash. And what is D by D dash? What is D? D is the real depth. And what is D dash? Apparent depth. So this is the derivation.
Okay.
Okay, take the screenshot.
Done, sir.
Here the important thing is to remember what is N1 and what is N2. So N1 is the medium in which the observer is present,
Yeah.
from where you are just watching.
Yes. Done, sir. Done, sir.
Okay, so this
Yeah, done.
formula, remember this formula, okay? N2 by N1 is equal to real depth divided by apparent depth. What is N2? N2 is the refractive index of the medium from where the light is coming. And N1
Okay.
is the refractive index of the medium in which the light is going, or you can say refractive index of the medium in which the observer is present.
Okay.
Now, one question based on this. So you can see here,
Sir, N2 is the medium where the object is present, right?
you
Okay.
can say that, right?
Okay. Okay.
Where the object is present. Ziad, are you getting the motion of the cursor?
Yes.
Fine.
Yes. Yes.
And just tell me now.
No, sir.
No. And
No.
now.
Yeah. Yes.
No. Okay. We have to solve this question.
Okay.
Okay. Now see. Suppose this is a bird. This
Yeah.
is a bird. This is a bird. And here is the fish
Yes.
under the water, and this is the water, and this water have the refractive index 4/3, and this fish is 24 centimeter depth.
Okay.
Okay, this fish is at a 24 centimeter depth from the surface of the water, and here is the air around it. Here is the air. So,
Yeah.
and this bird is at a distance of 36 centimeter from this surface, or from the interface which is separating the two medium.
Okay.
Okay. Now, first question. They are asking find the depth of the fish seen by the bird. Find the depth of the fish. See, this bird will see this fish. Try to see this fish, underwater fish. So they are asking, in actual, this fish is here, but for this bird, where will be the fish? Here also we have seen when we see the object underwater, so
Yeah.
it will be little bit, it will appear that the object is little bit lifted up due to the
Yeah.
reflection of light. So they
Yes.
want that. Okay.
Yes, sir.
So here what we will do, we will apply the concept of the real depth and the apparent depth. Answer number 1. Answer number 1. Now see, this fish is here.
Yeah.
This is the real, for 24 centimeter is the real depth of the fish. 24
Yes.
centimeter is the real depth of the fish.
Yes.
But for the bird, there will be some another depth.
Yeah.
Okay. Means, I mean to say that the image of this fish will be somewhere else. Means will be somewhere, means in the water. Okay.
Yeah.
It can be here also. Okay. Okay. So we will find what I have told you about, there is a relation between the real depth and the apparent depth. So n2 by n1 is equal to real depth divided by the apparent depth, divided by the apparent depth. And what is the n2? N2 is the refractive index of the medium where the object is present. And now tell me one thing, who is the object and who is the observer?
The fish is the object and the observer is the bird.
So your fish is object. So if your fish is the object, means the object will give the light. So
Yeah.
from this medium, the light will go.
Yes.
So n2 will be 4 by 3.
Mhm.
And what is the word here? Observer. So n1 will be 1.
Okay.
So observer is present in this medium.
Okay.
So n1 will be 1. And what is the real depth of the fish? 24 centimeter.
Yeah.
24 centimeter. So real depth is we represent by d and apparent depth we represent by d dash. Now what is
Yeah.
n2? N2 is 4 by 3
Yeah.
and n1 is 1.
Yes.
Now real depth we know 24 centimeter
Yeah.
and apparent depth we want to find of this fish. So
Yes.
from here you can find the apparent depth. So apparent depth will come out to be 6 3 the 18 centimeter. So the apparent depth of the fish will be the 18 centimeter. What does it mean? The fish will be somewhere here, according to the bird.
Okay.
This is just a rough diagram. Okay.
Okay.
So the fish will appear to the bird somewhere above the surface. So it is 18 centimeter.
Okay.
Okay. So they are asking depth of the fish seen by the bird. So can you tell me what is the depth of the fish seen by the bird?
18 centimeter, right?
Actually, the bird is here
Yeah.
at a distance of 36 centimeter. So what is the
Oh, so
total depth?
36
6
plus
plus
18.
right.
Okay.
So you can say depth of fish seen by bird is equal to 36 at this distance plus this distance.
Yeah. So
This is the apparent position. Apparent means this is just appearing to the bird.
yeah.
So 36 plus 18.
48. Right?
Yeah. No, 54.
Okay. Yeah. Yes.
54 centimeter. Next question. They are asking, after that they are asking, if this fish will see the bird,
Yeah.
then for this fish, what will be the height of the bird? Second question. So we will solve second question now.
Okay.
Now, can you tell me what is N1, what is N2 here?
N1 is 4/3 and N2 is 1.
Right. Because who is the observer? Fish is the observer
The
here.
fish, yes.
Fish is the observer.
Yeah.
So if the fish is observer, means the light will go towards the observer. And who is the object here?
The bird.
Bird. Bird is the object. So bird. So the light will go from the object. So N2 is the refractive index of the medium. N2 is the refractive index of the medium from which the light will go towards the observer. So from the bird, now the light will go to the fish. That is why the fish is able to see the bird. So N2 is 1 and N1 is equal to 4/3.
Yes.
Now this is the apparent position of the bird. This is the apparent position of the bird here.
Yes.
For this fish. And we want to find the, what I am saying, this is the real position or real height of this. Now what is happening now? This fish is seeing from the water and this bird is in the air.
Yes.
This bird is in the air. So here you can see this is the actual position, but due to the refraction we know the actual position according to the observer changes. Means there will be an apparent position according to the observer. So we will find that N2 by N1, same formula we will apply. N2 by N1 is equal to real depth divided by the apparent depth. Now N2 is 1 and N1 is 4/3.
Yes.
And what is the real depth or real height of the bird? That is 36 centimeter.
Yeah.
And apparent height of the bird will be d dash. So from here you can find it will become 3/4 is equal to 36 by d dash. So you can cancel it out. 3 ones are 3, 3 to the 6. So d dash will be 48 centimeter. Means from the surface, the bird will be somewhere here. The bird will be somewhere here.
Yeah.
At a distance of 48 centimeter. So this is the apparent position.
So that is what the fish is seeing, right?
Yeah. But in actual, where is the bird? This is the actual position.
Yeah, 36.
So what is this distance? This distance is basically 48 centimeter. So now can you tell me what is the height that the fish will see?
90 plus 29. 98 plus 29.
No. I am asking.
Yes.
This is the fish.
Yeah.
And here this is the actual position of the bird and this is the apparent position of the bird. Means apparent position means the fish is seeing the bird as bird is here.
Yeah.
This is known as the apparent. But to the bird it is appearing that, to the fish it is appearing that the bird is here.
Yes.
So can you tell me, according to the fish or with respect to the fish, what is the height of the bird? Fish is at this distance and bird is at this distance according to the fish. So can you tell me what is the height seen by the fish? 24 plus 48.
Yeah.
Okay. 24 because the fish is here. Okay. Yeah. 24 plus 48. So height of bird seen by fish is equal to this distance 24 plus 48. 24 plus 48, 72 na? 72 centimeter.
Yeah.
Okay, so take the screenshot.
Done.
Now, can you solve these kinds of questions?
Yeah, I think so. Yeah.
Okay. But you have to remember what is N2 and what is N1. And always
Yes.
you will take the height or the distance from the surface.
Okay. Done. Done.
Okay. So now we will see, have you seen the glass slab in your lab?
Glass
So,
slab.
glass slab. Glass slab is made up of glass and it is a slab also, it is known as the glass slab. So now we will discuss the shift through the glass slab. So what is the glass slab? Glass slab is basically made up of glass.
Yeah.
So this is the glass slab. And from this surface and from this surface, the refraction of light will take place. Suppose there is one object here.
Yeah.
This is the object here. And somewhere here is the observer. Okay.
Okay.
So now this observer is observing this object through this glass.
Yeah.
Okay. Like through this spectacle, I am observing the screen.
Yes.
Like this observer is observing this object here through this glass slab.
Okay.
This is glass slab. Okay, so now we will see how means where this object will appear to this observer. We will see. So refraction of light will take place. How the suppose one ray of light from the object is like this,
Yes.
and here is air, and here also the air. Around the glass slab there is a air. So the light ray is going like this first, and as the light ray is changing the medium, now from here the light is entering to the glass. So the bending of light will take place. And for showing the bending, how the light will bend, normal will be required. So this is the normal. As the light ray is going from denser to rarer to denser, it will bend towards the normal. It
Yeah.
will bend towards the normal. So means bend towards the normal like this. Okay, meaning it will go like this. So this light ray is bended towards the normal. Okay, fine. Now this light ray will go like this, and now this light ray is going, and this is a denser medium here,
Yeah.
and air is the rarer medium.
Yes.
So now the light ray is going from denser to rarer. Now the light ray is going from denser to rarer. So we will show through the normal how the light ray will bend. So the light ray will bend away from the normal. The light ray will bend away from the normal. Bend away from the normal. and say like this, the light ray will bend. So finally the light ray is going like this. And when you will produce this light ray, so this light ray will appear somewhere here like this.
Yes.
Okay, so when you will produce the light ray here, so finally this object will appear here. So what you are doing, you are just producing this light ray. The actual path of the light ray is this, but when you are producing this light ray backward, so here will be the image of the object will be there. This is the image basically. This is the image.
Okay.
And what is it? This is the object.
Yeah.
So now this thing, this distance is known as the shift. This distance is known as the small s, and small s is known as the shift. Shift means this O is the actual position of the object and I is the apparent position of the object
Yeah.
with respect to observer. So you can just elaborate it. You can write I is the apparent position of object with respect to what? With respect to observer.
Yes.
And O is the real position. Real position of object. One more thing we have, that is the thickness of the glass slab. Small t is the thickness of the glass slab. Thickness of glass slab. So when you will apply a little bit trigonometry and you will apply the geometry, then this shift will be given as thickness multiplied by 1 minus 1 upon refractive index of the glass. Okay?
Okay.
1 minus thickness into mu is the refractive index of the glass. So you can write here mu is the refractive index of glass slab. One more thing, these rays are paraxial. Okay.
Okay.
Rays from the object are there are some important point. Rays are paraxial. Medium on both side of the slab is same. You can see both sides of the slab there is air.
Yes. Yeah.
If apart from this air there is another medium, suppose you have dipped this glass slab into the water, so around both side of the glass slab there will be water.
Yeah.
So then the shift there can be given by thickness of the glass slab multiplied by 1 minus refractive index of the surrounding medium divided by the refractive index of the glass slab. What is mu s? Refractive index of surrounding. And mu g is the refractive index of glass slab. So now you can see distance of the object from the slab does not matter for the shift. Now in this formula there is no distance, so shift is not depending upon the distance. If the value of the shift is come out to be positive, okay, if the value of the shift is come out to be positive, then shift is in the direction of the incident ray. If the value of the shift is come out to be negative, that it is in the opposite direction of the incident ray. These things we will see in numerical. When we will solve the numerical, then we will see this thing. Okay, so now you can take the screenshot.
Done, sir. Done, sir. Done, sir.
This question is based on the same concept that we have discussed. So this is the glass slab here. This glass slab have the refractive index of 1.5 and thickness of the glass slab is 15 centimeter. Here is the observer and here this is the object. O is the object here. Now you can see this object is at a distance of 10 centimeter from this surface of the glass slab. And both side of the glass slab there is air. They are asking the shift. What is the shift? Apply the formula of the shift. When both side of the glass slab is air. Shift S is equal to thickness of the glass slab multiplied by 1 minus 1 upon refractive index of the glass slab.
Yeah.
What is the thickness of the glass slab? Thickness is 15 centimeter. So you will put here 15 centimeter. 1 minus 1 upon refractive index of the glass slab is 1.5. So here you will put 1.5.
Yes.
So it will be 15 and it will be 1.5 minus 1. It will be 0.5 and it will be 1.5. So when you will cancel it out, you will get 10, and when you will multiply it with by 0.5, it will become 5 centimeter. So means the shift is equal to plus 5. So if shift is positive, then it will be in the direction of the incident ray or incident light. So object is here, so light will be in this direction, light from the object will be in this direction. This is the incident ray, incident direction. So the shift will be in this direction, means this object will be appear somewhere here, and this distance will be 5 centimeter. Understood?
Yes.
This is the apparent position of the object, and here shift is positive. That is why this object is appearing here, and this is in the direction of the incident ray. Object is here, so the light rays will be like this. Incident direction will be like this. Another question. Now here you can see this is the glass slab and this is the glass slab, and this has the thickness of 15 centimeter, and an object is placed at a distance of again 10 centimeter, and here is the observer, and on both sides of the glass slab now there is no air, there is another medium, so there is another surrounding medium is there. So first see what data is given to you.
Yes.
They have given thickness of the glass slab 15 centimeter. They have given refractive index of the glass slab, that is 1.5. They have given refractive index of the surrounding. What is the refractive index of the surrounding? Ziad?
15, right? Oh no, wait,
2, na? Refractive index mu.
yeah,
2.
yes, 2.
Now, for finding the shift, what is the formula? When on both sides of the glass slab, there is another medium other than air. The formula is thickness multiplied by 1 minus refractive index of the surrounding medium divided by the refractive index of the glass slab. So thickness is 15 centimeter.
Yeah.
So 1 minus refractive index of surrounding is 2
2.
and refractive index of glass is 1.5.
Yeah.
So what you will get? You will get, it will be 15 and here you will get minus 0.5
Yeah.
and it will be 1.5. So basically when you will cancel it out, okay, so what we will get when we will cancel this 15 by 1.5, we will get 10. When you will multiply 10 with 0 minus 0.5, you will get minus 5 centimeter. Now shift is negative now. So what happens when shift is negative? When the shift is negative, you can see here. When the shift is negative, S is negative. So shift is in the opposite direction of the incident ray. Shift is in the opposite direction of the incident ray. It means that this object, na, you have this object. So this object will appear somewhere here. And this distance will be 5 centimeter. Now this time, why the shift is in this direction? Because shift is negative we got. And what is the direction of the incident ray? This is the direction of the incident ray. So incident shift is taking place in this direction, opposite to the direction of the incident ray. Got it?
Yes.
Now can you tell me from this surface where the object will appear? Mean at what distance the object will appear from this surface?
So can you repeat it? I didn't hear you there.
Actually, I am saying that from this surface, na?
Yeah.
What is the location of, what is the apparent position of the object? See, 10 plus 5, 15 centimeter. 10 centimeter, at 10 centimeter, the object is actually there. But for this observer, the object is here.
Yes.
So that is why I am asking from this surface. Okay, take the screenshot.
Done.
Okay.
Done.
Okay. So two formulas you have to remember. First is this,
Yeah.
means when on both sides there is air
Yes.
of the glass slab, then the shift is given by thickness of the glass slab 1 minus 1 upon refractive index of the glass slab. Another formula for the shift, when on both sides there is any other medium other than the air, so that will be thickness of the glass slab 1 minus refractive index of the surrounding medium divided by the refractive index of the glass slab. So these two formulas for shift you have to remember, and remember one thing, if the shift value will come out to be positive, then you will say the shift is in the direction of the incident ray. If the value of the shift is come out to be negative, suppose minus 5 centimeters,
Yeah.
then in that case you will say the shift is in the opposite direction of the incident ray, as in this case. Have you heard about the total internal reflection?
Yes, sir.
So today we will see how the total internal reflection takes place. What is the reason behind the total internal reflection? And what is the critical angle for two medium? So for understanding that, suppose here is one medium, here is another medium, and this is the denser and this is the rarer medium.
Okay.
This is the denser and the rarer medium. So the light ray, and this is the normal, okay, this is normal, and this is the interface separating the two medium. So in first case, this is the angle of incidence, suppose I1, and the light ray is going like this, and at here the medium changes, so bending of light will take place.
Yeah.
Bending of light will take place means angle of incidence is I1 here, means the light ray is going from denser to rarer medium. So whenever the light ray goes from denser to rarer medium, so the refracted ray here is, this is the incident ray. I'm writing. Okay, this is the incident ray. And what is this?
Reflected.
Refracted ray.
Reflected.
This refracted ray is coming from the denser medium and going to the rarer medium. So the refracted ray will move away from the normal, will move away from the normal. Now suppose this angle is I1.
Yeah.
Okay. Suppose this is another angle of incidence I2.
Yes.
After that, what you have done, you have just increased the angle of incidence. You have just increased the angle of incidence. And on increasing the angle of incidence, the angle of refraction will also increase.
Yeah.
So light will more bend away from the normal.
Yes.
This is the normal. In this case, light is bending more away from the normal as compared to here. Now, again you have increased the angle of incidence. Now this time the angle of incidence is I. This time the angle of incidence is I, and in this
Yeah.
case now what will happen? The angle of refraction will become maximum in this case, and the light ray will go like this, and the light ray will graze the surface like this. Means the light ray will go like this.
Okay.
Okay, you are increasing the angle of incidence, and at a particular angle of incidence the light ray is grazing the surface.
Yeah.
And what is the angle of refraction here? 90 degree.
90 degree. Yeah.
And this angle of incidence is known as the critical angle. Now can you define what is critical angle? The angle of incidence for which the angle of refraction becomes 90 degree.
Sir, can you repeat again that sentence?
Means the critical angle is
Yeah.
the angle of incidence
Yeah.
for which the angle of refraction becomes 90 degrees. Simple.
Yeah. Okay.
No?
Yeah.
My voice is okay, na?
Yes, sir.
Now we will see how the total internal refraction will take place. C is the critical angle. C is the critical angle for pair of media. Can you define the critical angle now? Na? The angle of incidence
Yeah.
for which the angle of
Yeah.
refraction becomes 90 degree.
Becomes 90. Yeah.
Or you can say the angle of refraction for which the refracted ray is grazing along the surface.
Yeah.
So this refracted ray is no problem, you can. Okay, so critical angle is clear. After that, if suppose this angle of incidence, this time what is the value of angle of incidence? That is equal to critical angle.
Yeah. Yes.
If this angle of incidence becomes greater than critical angle, then what will happen? Now this is the angle of incidence here, I.
Yes.
And this I value is greater than the critical angle between two surfaces or between two medium. Then there will be no refraction. There will be no refraction. Reflection will take place.
Okay.
So total internal refraction you can say takes place.
Okay.
This is angle of I and this is angle of R. And angle of I is equal to angle of R because this is the reflection here. What is here? Total internal reflection.
Okay.
Total internal reflection, and this is known as TIR. And now here the reflection is taking place without any mirror. Now condition for total internal reflection. First and the foremost condition, the light ray should travel from denser to rarer medium. So here the light ray is traveling from denser to rarer medium.
Yeah. Yes.
After that, the angle of incidence must be greater than the critical angle.
Yeah.
Now we will try to find out the value of the critical angle. How to calculate the critical angle? Suppose this is the denser medium and this is the
Yes.
rarer medium, and light ray is traveling from denser to rarer medium. So if this is the critical angle, means if this the value of I here is the critical angle, So what will happen? The light ray will graze along the surface like this. And
Yeah.
angle of refraction becomes 90 degree.
Yes.
Now apply Snell's law on this interface. Apply Snell's law. This refractive index multiplied by sin I.
Yeah.
Snell's law. So mu2 multiplied by sin of I is equal to mu1 into sin of R. Sin of R is 90 degree.
Yes.
So mu2 into sin of R. So it is mu2 into sin of
So sin
R.
90, right?
Huh. What is I? I is equal to the critical angle here. The value of I is equal to the critical angle. That is why this light is grazing like this.
Yeah.
And what is R? R becomes the 90 degree.
Yes.
So you can write mu2 into sin C.
Yes.
Instead of I, you will put C. Instead of R, you will put 90 degree.
Yeah. So sin 91.
Sin 91.
Yeah.
So critical angle, sine of critical angle, you will get mu2 by mu1.
Okay.
So how can we, what is mu2? Basically sin C is equal to, mu2 is the refractive index of denser medium and mu1 is the refractive index of rarer medium. So you can say sine of critical angle is equal to refractive index of denser divided by refractive index of rarer medium.
Okay.
So remember this. Now you can say if rarer medium is air, if suppose this medium is air, then what is the value of mu1? So mu1 is equal to 1. So refractive index of rarer medium will become 1. So you can say sin C is equal to we have done.
Sir, can I take screenshot?
Just a minute.
Okay.
Yeah, I'm just saying. Mu2 into sin I and mu1 into sin R. So mu2 into sin C, and it will be